Hello everyone, I am Dr. Janavi Chakrabarti, Department of Mathematics Assistant Professor, Vardhaman College of Engineering. Today in this video, I am going to discuss the solution of algebraic and transcendental equation by fixed point iteration method. So now let us see what is fixed point iteration method. So for this method, we first consider the equation fx equal to 0 and we choose 2 points a and b such that f of a and f of b should be of opposite signs. So if fa is negative, then fb should be positive. If fb is negative, then fa should be positive. Okay. Then by intermediate value theorem, we get that there is a root, there exists a root between a and b. Now next we will assume the initial approximation to the root, that is x naught equal to a plus b by 2, the points we have chosen. Now we will write this fx equal to 0 equation in the form x equal to phi of x. Okay. And so next is we need to choose x equal to phi x in such a way that the initial approximation x naught should satisfy the condition mod of phi dash x is less than 0. Okay. So now by the fixed point iteration method, we get that xn plus 1 is equal to phi of xn for n equal to 0, 1, 2, 3 and so on. So what we will get, if n is 0, then we will get x1 is equal to phi of x naught, x2 is equal to phi of x1 and so on. This is x1 equal to phi of x naught, x2 equal to phi of x1, x3 equal to phi of x2 and so on. Now let us understand this method with some examples. We will take one algebraic equation and one transcendental equation. Now let us look at this question. Here we need to find a root of the equation. Equation is given as x cube plus x square minus 1 equal to 0 by the iteration method, and initial approximation is also given, that is x naught equal to 0.8. So let us see how we can solve this problem using iteration method. So we first let this equation, we can let it as fx equal to x cube plus x square minus 1 is equal to 0. We will give this equation number 1. Also what is given? Given x naught is equal to initial approximation x naught is equal to 0.8. Now this equation 1, this can be written in terms of x equal to phi x in several ways. Look at here. Equation 1 can be written as x equal to phi x in such a way that this phi dash x should be less than 1. Okay. So how we can write equation 1? So first of all, we can write it as what is given, x cube plus x square minus 1 is equal to 0. So from here we can keep x cube this side and this side we can write 1 minus x square. So what you will get, x is equal to 1 minus x square power 1 by 3. Okay. So this is in the form x equal to phi x. Okay. So now what we need to check? We need to check that this is x naught. So we need to check this mod of phi dash x naught should be less than 1. So first of all, we need to find what will be phi dash x. So what will be phi dash x? Therefore phi dash x will be 1 by 3, 1 minus x square, 1 by 3 minus 1, that will give you what? And also minus 2x. So it will give you 1 by 3, 1 minus x square, minus 2 by 3 and minus 2x. So now we need to check what value it will give at 0.8, right? Okay, 0.8 is the initial approximation. So now we need to check mod of phi dash x naught. Okay, therefore mod of phi dash x naught, if you use the calculator, what value you will get? You will get 1.05, that is greater than 1. So we cannot use this one. Okay, since this absolute value of this phi dash x naught is greater than 1, we cannot use this because as per the condition we need to have modulus of phi dash x naught should be less than 1. Okay, let us see the next one. So next one, how we can find, what was the equation? X cube plus x square minus 1 equal to 0. Okay, so now you keep x square this side and 1 minus x cube that side. So what you will get? X equal to 1 minus x cube 1 by 2, which is x equal to phi x form, right? Now you need to find phi dash x. So phi dash x, you will get 1 by 2 1 minus x cube minus 1 by 2 minus 3x square. Okay, now you find what will be mod of phi dash at 0.8 initial approximation. So whether it is less than 1 or greater than 1. So this you will get 1.37, which is greater than 1. So we cannot use this one also. Now let us look at the last one. Okay, so number C, another form you can write it as x cube plus x square minus 1 equal to 0 is given to you. So how you can write? You can keep x cube plus x square this side and 1 that side. Take x common, what you will get? X square common, what you will get? X plus 1 equal to 1. So this will give you, therefore x is 1 plus x minus 1 by 2. Okay, x is 1 plus x minus 1 by 2, that is phi of x. Next again you need to find phi dash x from here. Therefore phi dash x will be minus 1 by 2 1 plus x minus 1 by 2 minus 1. So what you will get? Minus 1 by 2 1 plus x minus 3 by 2. Okay, now we need to check whether phi dash at 0.8, mod of phi dash at 0.8 is greater than 1 or less than 1. So you will get here 0.2, which is less than 1. So we can use this x equal to phi dash, we need to use this one for the iteration method. Now we know by the iteration method, by fixed point iteration method, what you have? X n plus 1 is equal to phi of x n for n equal to 0, 1, 2, 3 and so on. So here x n plus 1 will give you x n plus 1 is, what is this? Is the phi x, right? This is the phi x. So here it will be 1 plus x n power minus 1 by 2 for n 0, 1, 2, 3 and so on. So now we can find the successive approximations using this one. Okay, this is by fixed point iteration method. So now what will be the first approximation? First approximation will be if n is 0. So if n is 0, you will get x1 is equal to 1 plus x naught x0 power minus 1 by 2. Okay, x naught is 0.8, so you will get 1.8 power minus 1 by 2. So this will give you 0.7454. So similarly we can find the successive approximations x2, x3, x4, x5 and x6. So why we stopped at x6? Because you look at this x5 and x6, you look at this x5 and x6, this is giving you 0.7549 and this is also 0.7549. Since up to 3 decimal places it is same. Okay, here up to 4 decimal places also it is same. So we stop here and we can say that the approximate root is the 0.7549. So what we can say, x5 is equal to x6 is equal to 0.754 up to 3 decimal places, So the required root will be 0.754. The required approximate root is x equal to 0.754. Now let us look at the second question. what is given to you? Find the root of the equation 3x equal to cos x plus 1 by the iteration method. In this question, the initial approximation is not given, so we need to find it by ourselves. So what is given? Let f of x is equal to cos x plus 1 minus 3x, okay, equal to 0. Give this equation number 1. So now, as here initial approximation is not given, so we need to choose 2 points a and b such that f of a and f of b should be of opposite signs. So we know that there exists a root between a and b. So for that we need to make one table based on x values. What will be the f of x values? So first one we will take it as -1, second one 0, and third one as 1. So for -1 it will give us 4.54. f of x will be 4.54. So if x equal to 0, it will be f of x will be 2. And if x equal to 1, then f of x will be -1.45. Now you look at this table. For -1 it is a f of x is positive. For 0 also f of x is positive. But for 1 f of x is negative. Since f of 0 is 2, that is positive, and f of 1, that is -1.45, that is negative. So by intermediate value theorem, what we have? There exists a root between 0 and 1. Therefore, there exists a root between 0 and 1. This is by intermediate value theorem. So now the initial approximation, therefore the initial approximation is given by initial approximation to the root is given by x naught is equal to 0 plus 1 by 2. That will give you 0.5. So initial approximation in this method is given by a plus b by 2. So here a is 0, b is 1. So we are getting 0 plus 1 by 2, that is 0.5. Now equation 1. Now the equation 1 can be written as x equal to phi x form, right? The equation 1 in such a way that phi dash x naught should be less than 1. It should satisfy this condition, okay? So 1 implies it will be, what was equation 1? This is the equation 1, cos x plus 1 minus 3x equal to 0. So cos x plus 1 minus 3x is equal to 0. So what you will get from here? X equal to cos x plus 1 by 3. Okay. So here it will be phi of x. We need to find phi dash x. So it will be, what is the derivative of cos x? This will be 1 by 3 minus sin x. Okay. This will be the phi dash x. Therefore, mod of phi dash at x naught. What is x naught? X naught was 0.5. So we need to find this 1 by 3 minus sine 0.5. Okay. So this will give you 0.15, which is less than 1. That means it satisfies the condition. Okay. Which satisfies the condition? Which satisfies the condition mod of phi dash x naught should be less than 1. Therefore, by fixed point iteration method, we have, what we have? Xn plus 1 should be phi of xn for n equal to 0, 1, 2 and so on. So here what will be the xn? Xn plus 1. This will be xn plus 1 is equal to phi of xn is cos xn plus 1 by 3. Okay. n is equal to 0, 1, 2 and so on. Now we can put the value n 0, 1, 2 and so on. So first of all we will put n equal to 0. So we will get x1 as cos of x naught plus 1 by 3. Cos of what is x naught? X naught is 0.5 plus 1 by 3. So this will give you 0.6667. Okay, this is the first approximation x1. Similarly, we will get the successive approximation x2, x3, x4. Let us see. So look at this x2, x3, x4, x5, x6 approximations. So we follow the similar pattern. For x1 we have got 0.6667. For x2 we have cos x1 plus 1 by 3. So in place of x1 we need to replace it by 0.6667 and we are getting this 0.5953. Similarly we got x3, x4, x5, x6. So we stopped at x6 because look at this x5 and x6. We are getting 0.6071 and here also 0.6070. So up to 3 decimal places the root is same, right? It is 0.607. So since x5 is equal to x6 is equal to 0.607 up to 3 decimal places, therefore the required approximate root is x equal to 0.607. This is the answer. Thank you.